This is not working. Match that. That's better. Oh, it's so dim. I'm just trying to crash my computer now. It's better to do it now than in my second class. It's beautiful. So nice. All right, it sounds like you're done. So let's go to it. And I heard several people say either the right answer or the right method, but I'm curious, this group here, what was your method that you'd used to figure out the answer here? What is the answer? Or what is your method? What's your reasoning? You guys, anyone, you want to make Reagan do it?
I mean, I can do it.
Yeah, either one, anyone could do it.
I feel like it. I can do it. Yeah, that would be better. Okay.
Right.
So if we have 11 people, you start off with the first person. They're going to shake all 10 hands. And then you keep going down because once you start out with that one person shaking all the hands, you can't shake their hand again because that would be a repeat. So then the next person would shake, instead of 10 hands, then shake 9 hands. And you go all the way down and then you keep adding them together.
Okay, so something like this. 5 plus 4 plus 3 plus 2 plus 1. Beautiful. Excellent. Now, and so your answer is 55? Okay, so I heard 55 from over here. What did you guys do to do it? How did you know it's 55?
We followed the same method, but we actually started out with 11 until she kind of mentioned something about not starting out with 11, but like you couldn't shake your own hand.
You don't shake your own hand. So it's a similar situation.
Yeah, we started off with 11 plus 10 plus 9 and going down, but then you can't shake your own hands.
So you dropped off the 1 or subtract 11 for the 11 handshakes. What about the back group? Did you guys get it? Did you do something similar or did you do something different? Oh, you started at the top. Whoops, where'd it go? There it is. So with one person, there's no handshakes, right? And then 2 people, there's 1 handshake. And then did you actually simulate 3 people? You could do it. You could have 3 people all shake hands. And there's going to be 3 handshakes, right? Because if everyone, so then that's 3. And then what was 4? 4 handshakes? Wow. So here, I guess, are we talking about the same thing? So you have here, let's do it this way. Here's person 1. Oh no, where'd it go? Come back. Just a sec. There it is. Okay, so here's person 1. Here's person 2. Here's person 3. Here's person 4. There, okay. And then we're gonna, how about this? So person 1 shakes hands here, right? So this is what I mean. We could simulate it by drawing these lines. And then person 1 is done. And then person 2 shakes hands here and here. And then the only handshake left is this one. So isn't that 6? 6, okay. So 6 of them. There. So yeah, so you could go down this way and you would get exactly the same thing. And you might notice that there's this same pattern that the other groups figured out, but it's from a different sort of perspective, that when you add a new person, you're going to add as many handshakes as they need to shake. So when we add the 4th person, they have to shake 3 additional people. When we add the fifth person, they're not going to shake hands with themselves, but they're going to shake hands with four other people. So it's kind of like exactly the same reasoning, but in reverse, starting with one person and working your way up instead of starting with 11 people and working your way down. But it's the same math involved, so plus 4 and so on. Da, 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 da. And that gives you 55 there. Now, it is possible to figure out how many handshakes there are without doing the chart. So let me do that for you. Unless anyone, can you do it without it? Can you tell me a formula? That's what I want to know. Is there a formula? There is. You know there is, isn't there? But do you know how the formula works? Does anyone want to don't want to steal your thunder? It's part of the fun of doing math is learning about it, figuring it out. Okay, well, I'll just do it really quickly here. So let's just think about what I did at the very beginning. I shook hands. If I shook hands with everyone, I would shake hands with 10 people, right? Let's say we shook hands with everyone. Once again, everyone shake hands with everyone. Ralston, how many people would you shake hands with? 10 people, right? I shook hands with 10 because I am egocentric and I only think of myself, and so I don't think about you shaking hands. I shook hands with you. But when Ralston thinks about the handshaking, he shook hands with me. Okay, Zane, how many people would you shake hands with? 10 as well. Everyone here would shake hands with 10 other people. But when Zane thinks about his handshakes, he's counted my handshake, and I've done the same because both of us are only thinking about ourselves because that's the way we are. We're the center of the universe, right? At least until we're, I don't know, out of the toddler years, and I still haven't emerged apparently. But so you have 11 people, and each of those 11 people shook hands with 10 other people. Multiply those together. That's easy. It's like counting the number of ceiling tiles in this room. It's, multiply it together, and so you get 110. But then you have to take into account the fact that we're all toddlers, and we think of ourselves, not the other person. And so each handshake got counted twice. So divide this by 2, and there it is, 55. The reason why this is useful is because this gives us a way of computing the number of handshakes for any number of people. For example, let's say I have 500 people and they all shake hands with everybody else. Well, how many handshakes would there be? Well, once again, let's go through the reasoning. Every one of those 500 people shakes hands with 499 other people, and you divide that by 2 because everyone thinks only of their own shake, that I shook hands with you, but you think that you shook hands with me, so every shake got double counted, and that'll be the total. So this is, if I have n people, the formula is n times n minus 1 divided by 2. This is a formula that you may have encountered before. We're certainly, those of you who are in probability, you're going to be dealing with this. In probability, we have a special name for it. It is a binomial coefficient. But whenever I teach this, by the way, I teach this topic to freshman non-math people. So this is one of the topics that we use for the fun course, the general ed math course. So I don't tell them this part. So this is special because you're special, and I'm really excited because we can actually talk about this intelligently now. It's a binomial coefficient. So you may have seen this as in choose 2 back in discrete math, elementary discrete, or in foundations of math. So you may have seen it like that, or you may have seen it like this, in choose 2. So either one of those is the same. Your Texas Instruments calculators they'll look like that. You'll see it in CR somewhere, or I don't know, it's under math dot and then prob or something. But anyway, there it is. So that's the formula for the number of handshakes. The reason I'm starting out with this is because this will pop up a number of times, this idea, as we think about voting, this idea of how does math intersect with social choice issues. By the way, what are the social choice issues? We'll just run down them really quick, and then we'll actually get started with the voting. Is you have voting. We have to make a choice, right? We have to make a choice about president here in the fall. We have to make choices about issues and so on. So there's voting. How can we make voting as fair as possible? And of course, I honestly think that the way that we have evolved through the various centuries that we've been the United States of America that are uh, the way that we choose our president has become less and less representative of the country for a bunch of reasons, but the polarization recently has been has made it worse, I think. But that set aside, we can still look at this from a mathematical perspective. So we have voting. We have things like so part and parcel with voting. There are certain situations where different people have different numbers of votes. I mean, just as an easy example, think of a shareholder meeting. Shareholder meetings, each person has the number of votes equal to the number of shares that they own. So if you're voting in a shareholder meeting, you might have more votes or more power than your neighbor. And when you have a situation like that, it would be interesting to know, well, who has how much power? This is present in our current voting for president because different states have different number of electoral votes. Now, those electoral votes are approximately proportional to the number of people in the state, but nonetheless, it means that each state has a different amount of power or a different amount of say in terms of the president. California, biggest, has the most, and Texas and so on. But then well, once again, we get political here, but I'm interested in the mathematical side of that. Is how much power is it? Like individuals, we can actually figure out how much power we have in Ohio individually compared to someone in Wyoming, compared to someone in California, and so on. And paradoxically, it turns out that the small states actually individually, if you think of each person, they have more power in terms of deciding a presidential election, especially if we weren't so divided in terms of our polarized and segregated. So then the third thing is, since we're talking about choosing the number of electors for each state, that's an apportionment problem. So this happens not just with seats in the House of Representatives, but in other settings, we have to apportion resources. So how do we decide how many of these indivisible resources to give to each of the deserving groups, let's say. So let's say we were trying to decide how many faculty members to give to each department. And so we roughly allocate faculty members based on how many students are taking classes in those departments. It's not entirely equal, though. It's just the way it is. But so like I probably have fewer students than my colleagues in the psychology department. And so different departments have different numbers or ratios. But we would, if you have a department that only has a few students, like history, you probably have a few number of faculty members. If you have a large department, like, well, psychology, you probably have a larger number, or biology, a larger number of faculty members in general. So how do we allocate resources? That would be apportionment. So we're going to talk about those roughly, I don't know, once a week probably. We'll see how things go. Let me see what's first, though. We got to deal with the voting. So voting. So this is the basics of voting. And to understand the basics of voting, I need to vote. I need to vote on the best food in the cafeteria. So we're going to do that vote here. And then I'm going to show you, wait, should we do it? Just a minute. I have a fake group. We have 11 people. Yeah, we can just do the vote. Okay, so we're going to vote. So I want you to choose your favorite cafeteria food, and this is assuming that these are the only three options. So you have pizza, stir fry, and the glorious chicken patty. I can almost taste it in my mouth right now. But anyway, I don't want to sway anyone's vote, but I just want to remind you how golden crisp that chicken patty is, and how you can put your toppings on it, and it just melts in your mouth. It's delicious. But anyway, pizza, stir fry, or the chicken patty. So which one do you think is the best? What's your favorite? So in order to not sway anyone's vote, what I'd like you to do is to secretly write down your favorite on a piece of paper somewhere. So I will secretly write mine down right here. And I'm gonna hold my hand over it so you can't see. All right, so everyone has theirs written down. So I just don't want anyone to be like influenced by anyone else. Okay, now we can reveal. Okay, so there's mine. Oh, chicken patty. I think you. Well, let's start with pizza. How many people thought pizza was the best? Okay, there's one, two, three. Be proud of your pizza. One, two, three, four, five. We have five. Okay, five. Oh, that's unfortunate. I'm assuming that the other six of us like the chicken patty. Let's find out. Stir fry? No. Oh, two stir fry people. All right. Well, what about the chicken patty? That means four. Okay, four. Well, we're pretty close. We're pretty close. And I think that I think that I can make an argument that chicken patty is the best choice for us. You see, when we make this choice, take a look at the numbers here. And do you know what the word majority means? Like when we talk about a democracy, we always talk about majority rules, right? Majority rules. What is a majority, though? Do you know what a majority is? Does anyone offhand? It's okay. You can just shout it out. I'm not going to pull my phone out. I mean, I can if I have to. I know you know what a majority is. It's so simple. That's the problem. All right, I guess I can pick. I don't have you in my phone yet. I can pick you though. Let's see. Why has not my computer has not crashed yet? I thought it would by now. It'll crash during my second class, which is the one I don't want it to crash because I can just do this on the board. Okay, let me do random student here. Random student Roston. Roston, do you know what a majority is? Yeah, when over half of the population is in favor of something. So I ask you, has pizza won a majority? It has not, because half of the population here is 5.5 people. So we need at least 6 people. 6 or more would be a majority. Pizza is not a majority, but sometimes we settle for this second best, and this has a name. Pizza does have the largest number of votes. Do you know what that's called? Now this one I won't just pick because I was pretty sure everyone knew what a majority was. But does anyone know what it means? What it's called? The word we use when we say someone has the most votes, not necessarily the majority. What do you think? Yeah, it's like a popular vote, and it starts with the letter P. It's a short word. Well, it's not that short. Sounds like majority. I'll put it down here. It's called a plurality. Plurality is the most. So, and unfortunately, a lot of things are decided using a plurality. The problem with a plurality is not a majority. And we see this especially in our fractured, presidential elections as of late. Uh, let's see. I do not think that anyone has actually gotten a majority of votes. Did Obama in his first term? I should know this. You see, anytime you have more than 2 candidates in an election, here there's 3, it's possible and in fact likely that no one's going to get a majority. And so whenever you have no one getting a majority, it could be that, and this is probably true during the Trump administration, that Trump's first term, and certainly if Trump is elected in the fall here, it will be the case that the majority of people not only didn't vote for him, but I would suspect that the majority of people would list him as their last choice. Because why would you not vote for him unless he was your last choice? Well, maybe I'm wrong about that. I'm making a value statement here. I'm going to try my best not to get political, but it's kind of hard when you get examples like this. But just imagine for a minute that Trump wins with a plurality of votes. Now, of course, you get a majority of the electoral college, but that's not the same as a majority of the electorate. When he won before, he had a plurality. In fact, he had fewer votes than Clinton in 2016. But he won because of the Electoral College. So anyway, it could be that pizza has the most votes, but it could be that these 6 people hate pizza. Probably that's not true. But it could be the case, couldn't it? That these 6 people despise pizza and would not want pizza ever. And the pizza people might say, I could deal with some chicken patties. It's okay. Or maybe they prefer stir fry. So in order to capture that information, uh, we're going to actually go one step further than we normally go in an election and do what some states have started to do and some municipalities have started to do, and that is ask people not only for their first choice, but for their second choice and sometimes for their third choice. And the reason for that is it allows us to figure out a better way of deciding who is going to win an election. So let me just here illustrate this by showing you here, just as an example. Suppose that my favorite thing there is chicken patty. My second favorite, so I might do this. So you might do this on your paper. You have your first choice, your second choice, and your third choice. There we go. Good enough. There it is. So my chicken patty would be my first choice. I think my second choice would be stir fry. And my third choice would be pizza. So each of you would have a similar preference list. So this would be my preference. So this is my preference. And you can all make your own preference. If you don't want to write out the words, you could do it this way: CSP. And in fact, that's the way I'm going to list it in just a minute when I tally our votes. Okay, so you understand what you're going to do is you're going to actually extend your preference beyond the first place to go second and third. And by doing that, we're going to hopefully get a better idea of what collectively would make the most people happy. Like I said, if you have a bunch of people who are gluten intolerant, they're definitely not going to want pizza. And so we want to take that into account. And, so if pizza is definitely something that everyone hates, well, not everyone, but if the majority of people hate pizza, we don't want to choose pizza, even if the plurality prefers it. Okay, so let's go ahead and make a little thing here. And what I'm going to do now is I'm going to make something called a preference table. Preference table, or a preference schedule, depending on who's saying it, but I'll just call it a preference table for now, and I'll adjust preference. If only I could spell it correctly. Okay, so here is the number of votes, and then I'm going to put first, second, and third. Okay, so I will put my preference here: chicken patty, stir fry, pizza. And so if you have the same as me, chicken patty, stir fry, pizza, let me know. Raise your hand. Two of us. Just two of us? What's wrong with you people? Okay, just two of us. Okay, that's okay. So I'll put a 2 up here. So notice how I'm going to do this is I'm going to keep track of how many people vote or have the preference that is listed there. So let's do the same thing for the next one. What else do we have here? So those of you, let me guess, if you preferred so there were 4 people, weren't there, that said chicken patty was best? So that means that there must be some people who like this chicken patty pizza stir fry. Is that the one that the other people like? So how many people like chicken patty pizza stir fry? 2 of you. Okay, I guess that makes sense, because those are the only 2 ways that you can have those, right? All right, now this is getting complicated. Who else has a preference they want to share so I can put it on the list? So what about you, Sarah? You haven't raised your hand. What do you have for you? I knew that the chicken patty was the second best, but okay, stir fry. Okay, so how many people agree with Sarah and have pizza, chicken patty, stir fry? So we got, so Sarah, 2, 3, 4, 5. Is that right? 5. Okay, so Audrey, we haven't gotten you to raise your hand yet. What was your preference? Stir fry, chicken patty, and then pizza, like that? Okay, so that's Audrey. Anyone else with Audrey's preference? Okay, that's 2 of you. Oh, yours is different. Okay, then there's only one. Only one. So okay, so Zane, what's yours? Okay, that's 1. Okay, did I get everyone's vote? Is everyone represented up here? Wait a minute. I count 10, 11. Yeah, there's 11. Yeah, I guess everyone's counted. Now, there is one possible option that we don't have on this list. Does anyone know what it is? Yeah, so pizza stir-fried chicken patty. So for completeness, I suppose we could do this and say that no one likes that. And actually, since there are three options here, you probably, if you remember from your discrete math or foundations of math, you probably could have told me how many there, that you would have known that there's six. But can anyone explain why there's going to be six different options here? Six different ways people could vote. Yeah, yeah, just 3 factorial, because you have three options for your first choice. Then once you've chosen chicken patty for your first choice, you have only two options for your second choice. Once you've chosen stir fry for your second choice, whatever's left has to be so this is going to be 3 factorial, which is 6. So if there were 4 options on the menu here, there would be 4 factorial, 24 different ways that you could list off those 4 people. And if there were 5 options, you can see things get complicated pretty quickly. 120. 6 options, 720. So hopefully we won't have to deal with anything quite that complicated. But once you have more than 3 or 4 people on a ballot, things can get complicated quickly. Let's see. Oh, I should look it up. Yeah, I think it's the Irish elections for their parliament. They use a method where people write their entire list, and sometimes it's quite long. There might be 20, and they have the entire list, and they go through a process with that list. We'll talk about when we get to it. To determine who the winner is. But they consider everything on the list. That's the thing. It's incredible. So if you had 20 factorial, I don't even know what that number is offhand. But you can do it on your calculator, and you're going to find out it's a huge number. Okay, so now that we have all this information, we could start thinking about how we might use it. So how could you use all of this? Let me just see what's coming up here. Sorry. So let's see. Yeah. So here are the two questions that we're going to answer. Is how should we choose the winner of an election? That's question number 1. Like, what are the methods? Are there other ways other than just saying the number of first place votes? So there probably are, and I'll bet you we can come up with one here before we leave. And then the other question is, what would make whatever method we choose, what would make it fair? Or perhaps a better way of maybe turn this around and say, what would be unfair? And I guess fairness is a squishy top subject, so we're going to have to define what that means. So we'll do that mathematically, but we've already talked about plurality. You know what a plurality is: the most first place votes. Doesn't mean that you have a majority, though. A majority is more than 50% of the votes. So plurality is the most first place votes. Majority is more than 50%. So let's take a look at an example. There we go. Let's see. Sorry, I gotta use my glasses because I can't see. Yeah, this will do. Sure. Yeah, we'll do this one. Okay, take a look at this one for a minute. This one has 4 candidates. And notice that because not all of the different permutations, that's what we call those 3 factorial, not all of them are represented. We just left them off the table. So unlike what I did back here, where I put that last one in there, if you don't have anyone who has this preference, there's no reason to put it down. So we'll come back to our situation in just a minute. But before we do that, just a little bit of practice. Which one was I looking at? This one? Yeah, I think that's the one. Okay, so I have a couple of questions at the bottom there. Take a minute and see if you can work them out. I think that, if you can understand those 2 questions, then you probably understand most of what we just went over. So I'll give you a minute to try to figure it out, and I'll pick a rando to answer. What time is it? Oh yeah, we got plenty of time. Okay. All right, let's see how we're doing. And where are we next? Next volunteer. Audrey's the next volunteer. Audrey, do you know how many voters there are? 320? How did you get 320? Oh, yeah, that makes sense, doesn't it? It's kind of like what we did back here when we were checking to see if we had all the voters, is just add the numbers at the top there. You got 11. So, yeah, 320. That sounds right. Okay, so 320. Let me jot it down here. 320. Okay, next volunteer. We have Evan. How many voters do you need to have a majority? Ah, very good. So you take half. Whoa, come back to me. There it is. Take half and make sure it's more than half. So some people say half plus one, but that's not entirely true because in our case, we have 11. Half of 11 is 5.5. So it's really one half. It's more than one half. You just do one half and either add one or add one half. So very good. But you're all smart in math people. You can figure it out. So 161 is a majority. So the next question is, since we know what a majority is, do we have anyone who had, oh wait, first of all, do we have a plurality? Who's the plurality winner? So take a look, see if you can figure out who would win in a plurality election. Take a minute, I bet you can figure this out. It's not that hard. Well, Zane, do you know who would win in a plurality election? Beth, wait a minute, but Cal has 107 votes. Isn't that the most? How many does Beth have? Oh, yeah, I forgot to add the two together. No, I'm just kidding. You knew that. I'm just faking it. But yes, so there's Beth. Beth with 133 votes. All right, very good. And then the final question, does Beth have a majority? So, Sydney, what do you think? Does Beth have a majority? Oh, yeah, that's right, because 133 is less than 161. And so no, 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 no. So this is one of those situations where there isn't a clear winner. If you have a majority, it's pretty clear, usually, although, well, you'll see that as mathematicians, we can come up with all kind of crazy things where the majority is not the winner. But let's go back to our election here and just come up with, brainstorm a couple of ideas since we have about 7 minutes left. No, 6 minutes because we started a minute early. So I will adhere to that. So is there any other way? So remember what I'm looking for here. I'm looking for a way to decide who the winner is and a reason why that person should be a winner. So should it, maybe it should be pizza, and you might say this is why we should have pizza as the winner. But is there some way that we could decide who the winner is? And because there's no majority winner. So when there's not a majority, no majority. So what do we do? What do we do? Question mark. So does anyone have any ideas? How do we decide when you don't have a majority? Are there anything that we can do with this? And there's no wrong answer here, pretty much. You could say flip a coin. What do you think?
My mind went to assigning 3 to the first row so that like everything in the first row is going to get multiplied by 3.
Okay.
All the winners, and then the second row by 2, and then the bottom row by 1.
Interesting. So what you're saying, let me just see if I understand. So we have chicken patty, for example, has 4 first place votes. And so that each of the 4 first place votes is like 3 points. Okay, so let's do that. I like this. This is going to be the Zane method. So chicken patty is going to be 4 times 3. So tell me if I do my math right. So 4 times 3 for the 4 first place votes for chicken patty. And then 6, chicken patty has 6 second place votes. So that'd be 6 times 2. And then 1 times 1. Okay, excellent. Let's do this math. This sounds fun. So that's going to be 23 points. And then we'll do pizza. So this is going to be the Zane method. And I like it that this is sort of this is something that's reproducible. So it's not just flipping a coin. It's understandable. Like I could do it back with the Abe and Beth, that election. I could do the same thing, couldn't I? So so this is what we're looking for, is some sort of a method. What?
Math is not 23, it's 45.
Oh, yeah, yeah, 25. You're right. Thank you. Thank you. 25. Thank you for, yeah, correct me because it's early. I'm just as early for me as it is for you. Okay, let's do the same thing for pizza. So pizza gets 5 first place votes, and then we'll see where we are. And this is the only thing we're done after this. I'll tell you what to do for Thursday. And then how many second place votes? 3. So plus 3 times 2, because there's 3. Here's the pizza second place votes, and then 3 last place votes. 3 times 1. Did I do that right? And so let's see, that's 15 plus 6 is 21 plus 3 is 24 points. Oh, I'm liking the Zane method. And then stir fry, just for completeness, we have 2 first place votes, 2 second place votes, and 7 last place votes. So let's see, that's going to be 10, 17. Did I do that right? And so the clear winner is chicken patty. I love it. I love the Zane method. So notice that what the Zane method does is it tries to take into account all of the information here. That is like someone's first place choice, second and third place votes. This method is a real method that mathematicians have studied, and it is something that is used today in certain elections that we'll talk about when we get to that in our book. So it does have a special name, but we're going to call it the Zane method from now on. Well, until we have to call it something else. So what should you do? So I was glancing through. I think what you should do for Thursday is to do the homework for the very first lesson. These are divided into lessons, where it's activities. So you have activity 1, and that's on page 1, and you will find, where is it? At the end here somewhere. Yeah, we don't want to do all of this. This is boring. So how about just activity 1, numbers 1 through 6? Yeah, 1 through 6 is good. So 1 through 6, it's not actually on page 1. So it's pretty easy to find. So activity 1, I'll put it up on the screen here. I'll actually have a list. That was something that I was meaning to do, but I didn't get to for today. But I'll have a list of what your assignments are and stuff. So I'll put it up here, though. Activity 1. Problems 1 through 6. This is starting on page 1. It's all really easy. This is going to be basic. It will get harder, though. So if you're like, this is too easy, this is boring, don't worry. It will get harder as we go through this and we explore different things regarding voting. All right, thanks so much. I'm going to stop recording. I'm recording, by the way, because that's what I do. And that's why I was hoping.